Good afternoon, everyone. I welcome you all to this another module of security. Today, we'll be talking about what is secrecy and what is secret key capacity. So, like as we have been talking about, there are is becoming a key technology in individual's life, industrial environment, and the market of IoT is exponentially growing, and many IoT devices are hitting the floor every passing day. Now, in IoT system, the connectivity between the IoT end devices and IoT services, basically the main connectivity is provided by the wireless channels. And as we are easily, it is easy to say that wireless communication channels are quite easy to tap down, or eavesdropping or simultaneous listening of the ongoing communication is quite easy in wireless channels. Now, crypto, there are a lot of if we talk of the application layer of internet of things, there are a lot of cryptographic techniques which are available. A lot of researchers, they keep on upgrading those cryptography techniques for the application layer. But these cryptographic techniques are basically designed and developed without regard to the vulnerabilities at the lower layer of internet of things. So these cryptographic techniques are good to go for the application layer, but if we talk of the lower layers of internet of things, maybe for a network layer or for the sensing layer, so these the at the sensing layer, the devices which are present are small, and they are technically, it is impossible to apply these cryptographic techniques to the end devices of the internet of things. So it makes it quite difficult to directly apply or directly implement the existing cryptographic primitives to the internet of the things scenario. Now we'll be talking about this secrecy. So secrecy is basically is quite simple. Secrecy states that if information A is bound to be delivered between communication entities, let's say T1 and T2, then no other entity should get that information or should be able to decode that information. But due to the openness nature of the wireless communication, and open wireless communication is a basic or primary communication way in which the end entities, they talk to each other, or end layer, sensing layer is connected to the application layer. So wireless channel is only option in internet of things. So these internet or this open wireless channels, as I told, that are quite what do you call easy to what we say as eavesdropping. So these open communication, where if A is transmitting some information to B, it is very likely that C might eavesdrop it. C might eavesdrop this information. So this information as can be taken up by C. So the internet of things is required to develop some lightweight cryptography techniques to ensure the secrecy of the information. Now let's take an example that the IoT endpoints T1 and T2 can communicate with the sync, with the sync, that let's say that this S is your sync, and T1 and T2, they can communicate to the sync over wireless channel. Let's say T1 can talk over the wireless channel A, and T2 can talk over the wireless channel B. So the endpoint T2 can listen to the transmission between T1 and S through the wireless channel C to acquire the confidential information. Now, if the end T1 wants to exchange a secret key, or some confidential information is transmitted, or if T1 has to exchange some secret key or ensure that confidentiality of its transmitted information is maintained, it can exploit the physical properties of a wireless channel. It can exploit the physical properties of the wireless channel to secure the information by coding against point T2, by coding against T2. Now, you know, it can be coded against point T2, but in Internet of three scenario, point T3, T4, T5. So technically it is impossible to code any conversation from any entity, because there are thousands of entities which are present in Internet of Things. So the fundamental secrecy limits of various, fading wireless channel is characterized by lot of researchers across the globe. The theoretical basis of this secret key capacity is that the transmission rate, you know the this is transmission rate should be very high, at which the eavesdropper is unable to properly decode any information. And this very high means should be equal to and more than the capacities of two channels. That is, if this capacity of this channel is x and it is y, so it should be equal to x greater than or equal to x plus y. So this is basically details of communication engineering. But the Gaussian mail channel has better signal SNR than the YTAP channel. So for this, the signal to noise ratio has to be very much increased. Once this transmission capacity of the transmitted signal from this wireless channel is high, then the capacities of channel X and transmission capacities of channel A and channel B, let's say transmission capacity of one is X and one is Y, then this transmission rate should be greater than equal to X plus Y. In this case, it becomes difficult for the eavesdropper to, you know, he can get hold of information, but decoding the information will not be that easy, for this. Now, this is a very